here? No. Poster, very interesting topic. Understanding the interaction between water and polymer in thermosensitive hydrogel.
Hello.
Hello.
Can you hear me?
Hi. Can you please share your screen so we can see your poster and tell us a little bit about it in 2 to 3 minutes, if you can.
Wait a minute. Can you see it now?
We see the web page, not your poster.
Yeah.
Yeah, fine. I think that's good.
Because of the limits of the poster, some useful information was put on this PPT. Okay, this is a background. A few years ago, our group have simulated a very polymer. This is the ABA type triple block polymer, and the A part is the hydrophilic segment, and the B part is the hydrophobic. And this polymer, when you put this polymer onto the water, and it can be a solution. So this polymer can be available in water, and when it becomes a solution, this spherical material was in this solution, and when this temperature rise, this solution would be gel, the water gel, and when this temperature down, this gel was back into the solution. So some research has made to figure out what happened in it. So they found the worm-like material with the main reason because the tangle of the worms create a 3D network. And hello, can you see me now?
Yes.
Sorry. And the tangle of this worms micro create a 3D work, and we all know the 3D network was the key to a gel. So the worm-like material was the key to the 3D network. So what do we want the sculpture? What do we want to get information from the sculpture? First, we want to use the FTIR to explore the intermolecule interactions, and the NIR was to explore the interaction between water and the polymer. And this method, CWT and the PCA analyze was used. Here's my poster. We did this research with Professor Shaw. Yeah, we all know it. It's a good teacher, and this was some of our results. This was the original sculpture, and this was our CWT analyzed, and some peaks was found, and this peak was represent the SO waters, which means free water, and this was represents the other hydrobound waters, and this was the CH groups of CH3, and this was represents the CH groups of CH2. And also the limits of the paper, limits of the poster. Just the PC2 analyzed, and the PC1 was here. Yeah, this is the different concentrations was method. This is the low concentrations, and this is the high concentrations. This is the 15, this is 20, this is 30, and we can find there's only one peak at around 7101, and we can find this increased layerly. So this may present the S0 waters. We can find this results in other researches, and this presents the PC2 analyzed, and we can find one may peak at around 700, and this may present S1 waters, and tunneling point was found. So it is corresponding to our polymer LCST. Yeah, just this temperatures. So this S1 water may be the key to our polymer structures, and some more researchers were made to figure out how it changes. Yeah.
Thank you. Questions about this work to Xiong, to Mr. Xiong? Do I say your name right? Xiong. Any questions, comments? So I would just generally like to ask, do you think it is possible to replace in future using near-infrared temperature perturbation spectroscopy instead of, for example, the thermal analysis methods like differential scanning calorimetry? I think that would be highly useful. What is your opinion on that? Do you use something like thermal analysis method for investigation of polymers?
What? Can you?
So do you use thermal analysis methods for polymer investigation?
No, not yet.
It's not that I think it's necessary. I just think that those kind of destructive methods can be replaced by the methods basically that you are showing.
Okay, thank you.
I think that would be highly useful.
I will do it.
If there are no more questions for Mr. Xiong from China, I would like to ask again if Professor Bian is here. Okay, if she